This is discussion about this sequential circuit. So what's the difference between sequential and combinational circuit? Sometimes they will ask you question this also. So sequential circuit means your output is going to depend upon the present input as well as past states. So that's why sequential circuit having memory element. So first question is differentiate between latch and flip-flop. So many times students are writing the wrong answer. Latch is for the level. So latch is what? Level trigger device. Okay. When it will achieve the particular level of the clock. Okay. So like suppose for example, it will go like this. So when it will achieve this level of the clock, then it will be triggered. So it is the level trigger device and asynchronous type of the device. Okay, so still people are doing mistakes on this. And next we have flip-flop. So in the flip-flop, so it is already L4 level. So now flip-flop is what? Age trigger device. Okay, it will be triggered by either positive age or negative age. And it is the type of the synchronous device. Synchronous device means same clock pulse will be given to each state. Okay, asynchronous means only first MSB side device will get the clock pulse, remaining will be triggered from the output of the previous state. Next, we have different types of shift registers. So shift registers is going to shift the bit by bit. Okay, so here we have four types. Okay, or if you include the universal shift register also, then it will become the five types. So but universal shift register is going to perform the same operation what is being performed by these four shift registers. So four types are here: serial in, serial out. Second one is serial in, parallel out. Third one is parallel in, serial out. And fourth one is parallel in, parallel out. Okay. Next, we have about this state reduction. So that state reduction. So this is also important question. Maybe long question will come about the state diagram. You have to reduce the states. So state reduction means we are going to reduce the number of flip-flops in a sequential circuit. Okay. So if number of flip states you are going to reduce means number of flip-flops will be reduced. So here in the state reduction, we reduce number of flip-flops. Okay. So that is called as the state reduction. So still people are doing the mistake in the state reduction diagram. Draw the logic diagram of serial in, serial out shift registers. So serial in, serial out shift registers. So you can take example of 2-bit, 4-bit, 3-bit, something like this. So suppose we'll take 2 bits. So you will have here 2 flip-flop. Okay. And here you know that mostly we use the D flip-flop. Okay. So D flip-flop and output is Q. This is the Q bar. Again here output is Q and this one is what? Q bar. And whenever flip-flop is there, clock pulse. Okay. So the clock pulse we are going to give here same clock pulse is given to each flip-flop like this. Okay. So here name is serial input. So serial input means here input will be given serially. Now output of the previous is going to be the input to this. Again, this is the output. So from here you will get the serial out. So if you have 4 bits, you can design take 4 flip-flops. Okay. Here we have taken 2 flip-flops. So next we'll see the long questions. Okay. So now question is here, explain the logic diagram of SR flip-flop, okay, with truth table and characteristics. So SR flip-flop, this one, if you are going to add clock pulse to the SR latch, like we have concept of the enable inputs, so this SR latch will become your SR flip-flop with enable inputs. So that enable is being replaced by the clock pulse. So first they're asking explain the logic diagram of the SR flip-flop. So that logic diagram, so you know that, so that this one can be designed with the help of universal gates. Okay. So either you can use the NAND gates or NOR gates. So we used to design with the help of NAND gates. Okay. So here we have. So whenever we are designing the flip-flop means it consists of the latch. So latch is inside the flip-flop. That is the part. So now we are going to draw the part of the that will represent the latch. So for NAND gates we are using here. And latch is the cross coupled them, right? So that output of this one is going to be the input to the another one. Okay, so like this connection is there. So this is going to be Q, this is the Q bar, this is the S, this is the R, and here we have clock. So that clock pulse is important. Now we have to write the truth table for this one. So truth table here will have how is the value of the S and R and what is the present state and what is the next state. These things are there. So with the help of 2 bits, total 4 different types of combination is possible here. So now suppose when S and R both are 0, okay, then Qn present state is 0, next state also will be 0. When we have again S and R both are 0, if Q1 is 1, then next state will be also 1. So whenever S and R both are 0, so what is the present state? That only will be the next state. Okay. So this one in the short form also you want means you can write Qn plus 1 equal to Qn for these two combination. Condition is S and R both are 0. Next, what we'll have? 0, 1. Again, it is 0, 1. Q1 is what here? 0. Due to that state, present state. So here output is means next state is what? 0. So S is set. When S is 0, that means here R is 1 in this condition. So that is the reset. The reset means Q bar will be 1, Q will be 0. Again, we have this is the 0, 1 and Q1 is 1, that is the present state. So Qn plus 1 will be 0 since Qn plus 1 dash is the 1. Since R is 1, so that is the reset. Okay. Next, what we'll have? 1, 0. So when we have 1, 0, now S is 1, so set. Okay. So if Qn is 0, so it is what? 1. If Qn is now 1, then Qn plus 1 is 1. That will be the set. So for this, you can summarize like this. Qn plus 1 is what? Always 0. Whatever is the value of Qn. And for this, Qn plus 1 is what? 1. So you have to take this combination in the input side. Then only you can write what we are writing in the right side. So next, one more combination is what? S and R is 1 and Qn is 0. So here, when S and R is 1, so here this condition will be the invalid. Qn also will not be 0. So this condition is going to be the invalid. And this condition we are going to overcome in case of JK flip-flop. That will be called as the race around condition. Another next we have what they're asking? Characteristics tables. So in the characteristics table, here we are going to write S and R value on the basis of Qn and Qn plus 1. So this is also you can call excitation table. So this is very important when we have required the conversion from one flip-flop to another flip-flop. So now here Qn plus 1 is suppose 0. So then S is 0. When we have this one 0, 1, then S is 1. And when we have 1, 0, S is the 0. Okay. So in case of here 1, 0, this is what? 0. Okay. When it is 1, 1, then we have here don't care condition. So now what will happen? R is just mirror image of this. So here it will be have don't care 0, 1, 0. So this is the excitation table. You can remember here 0, 1, 0. Okay, and cross, and R is the just mirror image of this. So here S for this 3 value is same as the Qn plus 1. Okay, and 1, 1 is no, that is already invalid here. Very alert condition for this. Okay, so this is the characteristics table as well as truth table. Okay, now what they are asking, second question we have. So this is only answer of the first part. Second question what we have now, convert SR flip-flop to D flip-flop. So this is very important. Still students are doing mistakes. Okay. Already we have explained in other video also in that lecture clearly how to convert one flip-flop to another flip-flop. Okay. So if you feel that this is going to help you, then like more, share with your friends as well as subscribe also. So now here, what is the logic? What you are going to convert which flip-flop? SR flip-flop to D flip-flop. Okay. So that means you are going to design D flip-flop by using SR flip-flop. But still people will do the mistakes. They will do the K-map also correctly. But after that, when they're drawing the diagram, they're taking the D flip-flop as the main flip-flop and they're giving S and R as the inputs. Okay. So that mistakes should not occur. Then you will not get the marks. So here, the which flip-flop you are going to design here? D flip-flop you are going to design. So for the D flip-flop, now you require here truth table. Okay. So the flip-flop, which one we are going to design, for that we require the truth table. So truth table of D flip-flop is required. So D flip-flop here, D is the input, Qn is the present state, Qn plus 1 is the next state. So here you see what are the possibilities are there that you are going to get here. So now different combination will take. So suppose here D is 0 and Qn is also 0. So Qn plus 1 will be what? 0. Okay. D is 0, Qn is 1, Qn plus 1 and still will be 0. Since D is the transparent flip-flop, what is the input? That is the output. So here D is 0 in both case. So that's why here Qn plus 1 is what? D. That is the characteristics equation of the D flip-flop. So now here D is 1, Qn is 0. So then Qn plus 1 will become 1. Now again D is 1, Qn is the 1, then Qn plus 1 is the 1. Okay. So like this you have to see this. Now apart from this, next what we required? The from which flip-flop you are going to design, for that you require the excitation table. Okay, so here excitation table of which flip-flop? SR flip-flop is required. From which flip-flop we are going to design. So just now we have seen that before this characteristics tables, so that is the excitation table. So that you have Qn plus 1, and you will have S and R. Okay. So generally, if they're asking you questions like this, both part will not be same. Like here, SR is there. They will give you different combinations. So now here with this 0, 0, 0, 1, 1, 0, 1, 1. So just now we have seen S value was 0, 1, 0. This is cross, and R is the mirror image. So 0, cross, 0, 1, 0. After this, important is the conversion table. So conversion table, now we are going to take the help of this both table. So that truth table of the D flip-flop, we are going to use as it is. So here we'll have D, Qn, Qn plus 1, then we have S and R. So here on the basis of this, we are going to write D in terms of S and R. That is, we are going to do in the conversion table. So now here, you should see the truth table of the D that we are going to write here as it is. So we have 0, 0, 1, 1. And this was the combination 0, 0, 0, 1, 1, 0, 1, 1. This is same. What we have here, truth table, same thing we have copied here. Now we are going to use this excitation table. So you see that when Qn plus is the 0, 0. So now we'll look at Qn plus 1. So what is value of S? S is 0. Okay. R is don't care. Now when, again if you see that Qn plus 1 value is what here? 0, 1. So for the 0, 1, what is S value? S value is what? 1. Okay. So 1, 0, where is the 1, 0? 1, 0 is here. So here you have to look exactly same. So here we have 0, 1. Okay. So for the 0, 0, 0, 1. Okay. So how we are going to write the combination on the basis of that? So here what we have done means that truth table we didn't write as it is. Okay. So truth table, what was here? D truth table. That truth table we need to write as it is. Otherwise here again that combination will become wrong. So make a small correction here. So what was the value here? Truth table, you see, we have 0, 0. Next is the 1, 0, 0, 1, 1, 1. We'll not write as our wish. How we have written the truth table here, on the basis of that we'll write. Otherwise, you have seen that mistakes is going to occur. So now first is 0, 0. So that 0, 0 we'll see here in the excitation table. So S is 0, R is the don't care. Now when we have 1, 0, so what we have? 1, 0 is here. So S is 0, R is 1. Okay. Now again here what we have? 0, 1. So 0, 1 is where? This one. So S is value 1, R is 0. And last 1, 1 means S is don't care, R is 0. So now after this, you have to go for the K map. So this K map, you are going to take D and Qn as the inputs. So when D and Qn are you're going to take as the inputs, so you will have 4 square box. Okay, here. So Qn plus 1 will not take as the input. So D, and this is the Qn. So this is 0, 1, 0, 1. So suppose this one we are trying to draw for the K map for the S. Okay, so what we'll get here? For the 0, 0, S value is what? 0. So when it is 1, that only you can concentrate. Okay. So when it is 1, D is 1 and Q1 is the 0. Yes. So that is here, or will take all values. Don't care is also there. So that is going to help us. So 0, 0, S is 0, 0, 1, S is 0, 1, 0, S is 1, and this one is the 1, 1 means this is the don't care. So finally, now here we can make the pair by using don't care. So finally, this is row wise common is what? D. So finally, what we are getting here? S equal to D. Okay. So similarly, now we'll go for the R. So again, two inputs. So you should careful. Qn plus 1 we are not taking as the input. So here we have D and here Qn. So finally, 0, 0. This is the don't care condition. Here 0, 1 we can write. Okay. 0, 0, don't care condition for R. Next we have 0, 1. 0, 1 is the what here? 1, and remaining 2 are the 0. So finally, what we have here, by including this don't care, we can make the pair. So this will be row wise, what is the common? D. So finally, R is equal to D. So R is equal to what? D dash. Okay, not D, D dash. Row wise common is what? 0, that is the D dash. Okay. So many times people are doing up to this correct, but after that, they are doing the mistake. What mistake they have done? So here we are going to design D flip-flop by using SR flip-flop. So SR flip-flop is the main flip-flop from where you are going to design. So this flip-flop will be our SR. Okay, this is the S, R, and this is the Q, and this is the Q dash. And here what we have? Clock pulse. Now already we got the expression, okay, for S in terms of D. So D is same as the S. So that D input is connected. R is what? D dash means we have to use the inverter. Okay. So like this we have designed D flip-flop by using SR flip-flop. So many times students are writing D inside, SR outside, and finally they are not able to get the proper marks. So that is very important here. So next we'll see another long questions. So this is the difference between synchronous, asynchronous. Many times they're asking. So these are the important points. So that's why I've written here. Okay, so here on the basis of clock, synchronous means you know that each flip-flop will receive the same clock pulse. Asynchronous means only first stage is going to get the clock pulse and remaining will be triggered from the previous. Speed, so now each and every having a clock pulse, so it is faster, it is slower, propagation delay will be less here. In case of synchronous, in asynchronous more complexity, circuit is little complex, okay, but here asynchronous is simple. Power consumption is here higher due to additional gate, here lower. Reliable, it is the more reliable, okay, stable, it is the timing issue is there. Cost, it is higher due to extra hardware, lower, and it has high speed of operation, it has low speed of operation. So as per marks, 5 marks means minimum 5 difference you should write. Okay. So these are the important difference between synchronous and asynchronous. These are the questions they have asked. Now you have design explain the 4-bit ring counter using the D flip-flop. So here see they're asking you 4 bits, and this one is this ring counter whatever is given here. This is the example of the synchronous type counter. So synchronous type counter means each flip-flop is going to get the clock pulse, same clock pulse. So here how many D flip-flop you have to use? Since it has 4 bits, so 4 D flip-flop is required here. Okay. So first we'll have D flip-flop. So why everywhere you are using D flip-flop means it is the more economical. Okay. And this is Q, this is the Q bar. So similarly, Again, we have D. This is the clock pulse. This is the Q, and this is the Q bar. Again, so like this 4 we have to take. Why I'm drawing here? So that you should not do the mistake. Many times people are not able to give the clock pulse also. So you have to keep in mind, I focus here what mistakes you used to do, students normally used to do. So now here clock pulse, since it is the example of ring counter, Johnson counter example of what? Synchronous. So same clock pulse is given to each flip-flop. So first you can connect this. Apart from this, you want means you can give the reset connection also to each flip-flop. Okay. So now here in case of ring counter, now what you will see that previous stage output is the input for the next. Output, input, output, input. Now it's a ring. So it is the circular like the ring. Okay. So output, last output is being connected to the first input. Okay. That is the ring counter. Ring. Okay. Whereas if Johnson counter means only change is that in place of Q, we have to take the Q bar. From that, we will give the connection. This is only a small difference, but still people used to do the mistakes. And here we have only 4 unique states you are going to get. Suppose, so for the, we have taken here state QA, QB, QC. So this is our QA, this is the QB, and this is the QC, and this one is the QD. So every year we are going to take the output. So this will be like a serial in parallel out. Okay, everywhere we are going to take the output. So this is the application of the shift registers in the ring counter. Sometimes maybe they'll ask the question how shift registers work in the ring counters. So now here see that QD is going to become input, okay, to the first one. So that's why this came here and these are shifted, okay. Whenever clock pulse is going to come, it is shifted. Again, this 0 is going to come here and these are shifting from previous to next. Again, this one is coming here. So again, shifting takes place. Like this is going to shift. Again, this one, after 4th clock, it came here and it is shifted here. So what you are saying that this and this both are same state. Okay. So that's why here we have only 4 unique states. Apart from this, we have already discussion in the separate video. What are the unused, and used states? That all discussion is there. Okay. So in case of Johnson counter, what are the benefits? Okay, same timing waveform is shown here. This is the clock pulse. So now here in this situation, see that how this Q is what here? 1. Remaining are 0. Now this has this one Q2 came here, so this becomes 0, and this QA is shifted here, so this is 1, 0, 0. So now again, this is 0, 0, this is the 1, this is 0. So same situation you are going to get here 0, 0, 1. This is shifted. Now here 1, 0, 0. Next clock pulse, after next clock pulse, what you are saying again, you will get this one. Like this here, it is going to be change from one state to another state. So this is how ring counter is going to work. And next you have about another thing is about this race around condition in the JK flip-flop, and this convert the JK flip-flop to T flip-flop. So in this situation, if you see that, we'll go a little fast or it's taking much time. So we can, so here a race around condition, just now I was talking. So in case of SR flip-flop, what we have there, when it is 1, 1, okay, when both input was what? S and R, both was 1, 1. Okay, S and R both are 1. So that was the what? Output was the invalid. So that's why in that situation, we are not able to get the what is the Qn and Qn plus 1. So that is going to overcome in case of JK flip-flop. So when J and K both are going to become 1, in that situation also we'll have proper output. Okay. So whenever clock pulse will be applied there, so output Q will be going to be toggle. Okay, it will be toggle as long as clock pulse is applied. So that is called as the race around condition. Okay. So now again, if you want to overcome of this, so you have to make this clock pulse as the at high level will make for the less duration, and it is again being used in the master slave flip-flop. So another we have JK master slave flip-flop, their concept is also there. Okay. Another what we have, convert this JK flip-flop to T flip-flop. So now here you are going to design T flip-flop by using the JK flip-flop. So again you require the T flip-flop truth table is required. Okay. Truth table of T flip-flop. So truth table of T flip-flop you have to write. Again you have to write the excitation table of the JK flip-flop. Okay. And finally you have to go for the conversion. Like this situation is going to come. Okay. So maybe this one we'll discuss again later in another video. Okay. So thank you. Like, subscribe as well as try to secure maximum marks. Okay. Confusion should not be there. Okay. Thank you. Thank you very much.